Okay, and so the last in our series of thinking about light bulbs being resistors is this one, which is which one is brighter. And I think a lot of you remembered from the recitation that somehow the 60-watt bulb is brighter, but didn't quite remember why. So I'm going to go through this a little quicker than I would have normally because I spent a lot of time on the two previous questions, 11 and 12, talking about this. So if this is too much, then go back and watch those other videos first. But just to recap, light bulbs, think of them as resistors that light up when they have current through them, and their brightness depends on how much power goes through them. So light bulbs with more power in them are brighter. So the equations for power is that power is current times voltage, or it's current squared times resistance, or voltage squared over resistance. Any of those will work. And the trick here is always to figure out which equation is the easiest to look at. So usually you're looking for an equation where sort of one of the three variables we know doesn't change, and then you can kind of reason out what's going on with the other two variables. What is stamped on our light bulbs is a number in watts. But that's very, very misleading from a physics and a circuit point of view. What that 60-watt light bulb means is that when it's plugged into 120 volts of AC current coming out of your wall, it will dissipate 100 watts. That light bulb is a resistor. It is not a wattager, okay? So what we need to do is figure out which of these two light bulbs actually is the bigger resistor. So I know that when plugged into 120 volts, this will dissipate 60 watts, okay? So that 60-watt light bulb, when plugged in to 120 volts, will dissipate 60 watts. So let's figure that out. So P is V squared over R. And when I plug it into 120 volts, this one is 60. 60 watts is 120 volts squared. And this one is that 100 watts is 120 volts divided by R. So which one is a bigger, so this one is more power, which means that that one must be the smaller resistor. All right, this one is less power, same amount of voltage, so this one must be the bigger resistor. So this one right here is the smaller resistor. Okay, so this is kind of, now we've used that information, we don't need to use that anymore. Because this light bulb, when plugged into whatever battery this one is not going to dissipate that amount of wattage anymore. So now the question is, we now can rethink of this as a circuit that looks like this, where this is the big R, and this is the small r. And now we can figure out which of these equations is good to look at to try to reason out how much power is going to be used and which one is going to dissipate more power, because the one that dissipates more power will be the brighter bulb. This is two light bulbs in series, so they will have the same current. So I am looking at this one. If you wanted to use the other two, you could use the other two, but it would require some more work and some more thinking. But since I know they have the same current, I know the relationship between the resistances, I can use this equation to rationalize which one's going to dissipate more power. So I have that power is I squared R. So whichever one has a bigger R, they have the same current. This one is bigger for 60 watts. Therefore, that's bigger for 60 watts. Okay, so the 60-watt bulb will be brighter because it's a bigger resistor. Set up in this circuit, the bigger resistor is the brighter one.